Hello everyone. Sorry for the extremely late video. I was doing research on access line bounding boxes, specifically the collision resolution. So let's get started. So an access line bounding box is pretty much a box with a half extent and a center, both of which are vector 2's. And of course, you can determine whether they are intersecting. So of course, this one isn't, and this one is. And the way to find them, pretty much, is you have two access line bounding boxes, and we need to find the distance between them. Then we use our half extents to shorten the distance, so then it would be corner to corner. So let's get started implementing this. So here, where we left off, I'm going to create a new package. I'll call it collision. And we'll create a new class, AABB. And of course, this will have a couple vector 2f's for the center and half extent. So now that we have our access line bounding box, we'll need a public boolean, and I'll call it is intersecting, and we'll pass in another access line bounding box. I'll call it box 2. So essentially what we do is we create a new vector 2f, and I'll call it distance, and this will equal to box 2 dot center subtract with our center, and we'll put this into a new vector 2f. So now we have the distance, and in order for us to be able to easily test this, we need to set it to the absolute value. So distance.x equals float math.absolute value distance.x. And we'll need to do the same thing for the y. So now distance is the absolute value, pretty much, of the distance. All we need to do is subtract both of the half extents. So distance subtract, and we can just do our half extent and add box 2 half extent. And make sure you put in new vector 2f. So now we actually have the correct distance. All we need to do now is return the boolean. So we'll return distance.x less than 0 and distance.y less than 0. So now that we have our is intersecting method and it's complete, Let's go ahead and come to the main, and I'll create a few AABBs, box 1 and box 2. So the first one, the center will be at 0, 0, and the half extents will be 1, 1. I'll also create box 2. Box 2 would be 2 units over to the right, and will have the same extents as box 1. So now, if box 1 is intersecting box 2, then we'll print out the boxes are touching. No, not touching. Intersecting. So right now, both the boxes are right next to each other, but they are not intersecting. So when we run, they are not intersecting. So now, if I move this over 1 unit closer to box 1, as you can see, the boxes are now intersecting. So let's get started on collision resolution. I'm going to create a new class. I'm going to call it collision. And collision will have a public vector2f distance and a public boolean is intersecting. And of course, I'll have a constructor for it. Oh. Boolean. Okay. That's pretty much all we need for this class. This class will help us with the collision resolution. So in AABB, I'm going to tamper with this class here. So instead of returning a boolean, it's going to return a collision, and it's going to be called getCollision. So pretty much all we need to do now is change the return, and we'll return a new collision. We can keep this. This will be the second parameter of it. And the first parameter is distance. And that should be it for getCollision. There's one last thing we need to do in the AABB class, and that's a public void correct position with an AABB of box 2 and a collision for the data. So create a new vector2f, and I'll call it correction equals box 2 center and we'll sub our center into a new vector to f. And now we have the distance again. This distance, to be more correct, not the distance we need. And now we need to do if data distance.x is greater than data distance.y, then we'll be pushing along the x-axis, and if not, then we'll push along the y-axis over here. So all we have to do now is test for our correction real fast. So if correction.x is greater than 0, then center add data distance x and 0, else center add negative data distance x 0. And then it's pretty much the same thing for the y. Just swap these variables around. And of course, change them to y. So that's pretty much it for the collision response. Now we have to change a little bit in the tile. So in tile, we're going to have a new variable for the tile. So we'll have a private Boolean solid. Then we'll have in the constructor this solid equals false. So they're not solid by default. Then we'll create a setter, public tile set solid. This solid equals true, return this. Then we'll have a public Boolean is solid. So now we have these two. We can come back up here and I'll make test2 solid. Perfect. Now we need to go to the world and create an array of bounding boxes. So private AABB array of bounding boxes. And of course, bounding boxes equals new AABB width times height. In set tile, we're going to change this a little bit. By change, we'll add to it. If tile is solid, then tile, oh, not tiles, sorry, bounding boxes at x plus y times width equals a new AABB with the center with the center being at x times 2 negative y times 2, and the half extent will be 1, 1. And then if it's not, then bounding boxes at x plus y times width equals null. And now we need another get tile. So I'll just copy this and paste it. And instead, it'll be AABB, and it'll be called get tile bounding box. And this will just return bounding boxes at x plus y times width. And that's pretty much it. So now that our world pretty much supports the bounding boxes, we can go into the player and create a bounding box for the player. So the bounding box will equal to a new AABB. The center will be new vector 2f of transform pos x and transform pos y. New vector 2f of 1, 1. And that should be it for the player. Next, we have to collide with them, pretty much. We have to determine if they are intersecting. So, in the update method, under where you move them, we'll create an AABB array called boxes equals new AABB. We'll go with 25. 25. So essentially, we're getting a 5 by 5 area around the player of bounding boxes. That way we don't have to collide with the whole world, pretty much. And next, we'll set these. So we have two for loops here. If I is less than 5, then we keep going, and the same with j. If j is less than 5, then we keep going. And we'll have boxes at I plus j times 5 equals world get tile bounding box at I never mind. I'm going to do this real fast. And we need our position to help with this. So transform pos x divided by 2 plus 0.5f. Put these in parentheses. And we'll subtract 5 divided by 2. And we'll also put this in parentheses as well, and cast it to an int. Then all we need to do is add I. Same goes with the y-axis, except I would be j, and this would be negative transform pos y. So this should get everything around the player for the bounding boxes. Now all we need to do is just intersect with them. And instead of intersecting with all of them, we'll only intersect with one of them, and that would be the closest bounding box. So we'll create an AABB box equals null. So we'll create another for loop. So this time it would be int I equals 0. I is less than boxes, the length of boxes, then I plus plus. So if boxes at I is equal to null, or I'm sorry, not equal to null, then if box is equal to null, box equals boxes at I. Other than that, we'll create two vector2f's, call one length 1, and that will be box get center, and we'll subtract our position. Form pos y into a new vector. So now we have length 1 and length 2 will be boxes at I get center, and we're going to be subtracting the same amount. Now we have to test which is greater. So if length 1 dot length squared is greater than length 2 length squared, then box equals boxes at I. So basically we're getting the distance of them both, testing which one is greater than the other, and then just setting it. And the reason why we're using length squared is so we're not wasting CPU power on finding the square root for the length. So it's just easier to use the length squared than it would be just to use the actual length. So now we can test this out. Almost. I forgot to have collision pretty much. So we'll create a collision here. I'll call it data equals bounding box is, or get collision with box. Then if data is intersecting, then we'll correct the bounding box. So bounding box, correct position, box, and data. And that should be it. So here in the main, I'm going to change a few tiles around. I'm going to move that over 5, 6, and 0. Let's run, and we get a null pointer. Okay. I forgot to do this. If box is not equal to null, then we can do all of that. And it's not working. Okay, so I figured out exactly why it wasn't working. And for one part, we're not setting our transform pos x and y. We could just do .set to bounding box get center. We weren't doing that. And we're not updating the center of our bounding box. So bounding box get center set, and we'll use our transform pos x and our transform pos y. Okay, so now everything should work properly. Of course, our collision system here, it's good, but it's not perfect. I'll show you an example. So here we have a little L shape here. I don't know if the capturing is taking that in, but if you can see, it's glitching around between the two bounding boxes, and well, that's not good. That's if you're holding two buttons up to it into the corner. Other than that, it works fine. Besides up here. And we can simply fix this by going into the player and doing this twice. So if the box is not equal to null, then we can paste pretty much the same thing inside. And we can get rid of this. Then data equals the new bounding box. So we're basically getting the closest box, then we're colliding with it, then we're getting the next closest box, and we're colliding with it. So this should fix the problem here, and it does. So that's good. And as a little bonus, our camera, it follows the player like it should, but wouldn't it be cool if it was more smooth? In that case, let's go ahead and do camera, get position, and we'll use LERP for, this is for linear interpolation. And we can do new, or no, not new, transform dot pos multiplied with negative world get scale, new vector 3f, and then t would be the delta. And you can experiment with this. This changes how fast the camera would keep up with the player. So let's take a look at it real fast. Camera's a little more smooth. If we decrease the value, then the camera would have a tough time keeping up with the player. I don't know. It's something you can choose to have it. I personally like 0.05. Well, anyways, that's all for this video. This is a pretty long video. And I'll see you in the next video.